All right, today we're going to do a little blast from the past. We're going to go through the KISS GUI flight controller setup. So let's go through the configurator, see how simple it is, and see if everything's there that you'll need. So the quad we're going to get set up is this one. This is a dual flight controller rig. I have a KISS flight controller on the top and a Betaflight flight controller on the bottom. Just regular BL Heli S ESCs. We're going to do some testing, logging on both because they both do support logging. And we're going to peel back the onion on KISS. So that's future content to come. If you're not subscribed, please do hit the subscribe button down below. And without further ado, let's get the KISS configurator downloaded and get this flight controller set up for this quad. So what you can do is just go to your browser of choice, type in KISS Configurator in any Google searching, and then go ahead and hit this top link here to download the configurator. That will take you to the KISS site. It's right here, the GUI for Windows, Mac OS, or Linux. And here you can find it takes to the GitHub repo where you can download whatever you need here. Once you have the zip file open, just grab the folder right here that says KISS GUI and you can just drag that onto your desktop or anywhere on a computer that you want it to reside. There's no installation or anything, you just need to unzip it. From there, you just open the folder that you drug and then you can launch the configurator right through here. There's this KISS GUI EXE. You can make a shortcut if you're on Windows for that, just by right-clicking and hitting Create Shortcut to Desktop. So, however you want to do it. Now, if you connect your KISS flight controller to your Windows PC, Linux, Mac, whatever, and you do not see a COM up here, like a COM 10 or something of that nature show up, you may need to go ahead and download the CP210 driver. That's the interface. It's kind of an older interface. Betaflight doesn't use it anymore, so you might not have this issue if you're saying like, well, I connect flight controllers with Betaflight or Falco X or whatever, and I don't have these issues. The CP210 is an older driver, so you might need to download that yet. Once you're on their page, go to downloads that you'll see right here, and then you can see your different flavors that you can get this downloaded from, again, Windows, Mac OS, whatever. I have a brand new Windows 10 machine. I didn't install any CP210 drivers and never needed it for this, so it's unlikely if you have a Windows machine that you'd need to do that, but I have seen some comments on other videos, so I wanted to put that out there. Of course, if everything is in order in that regard, just go ahead and hit connect. And then this is the configurator interface that you're going to have. You're really dealing with about 4 tabs here. I guess 5 tabs. You have the configuration, the advanced, the output, rates, and then TPA. We'll need to go through all 4 of those. One of the first things you're going to want to do is make sure your flight controller board is on the latest firmware. So we're going to go over to FC Flasher. And then you can pick local or remote. This is if you download it from the website direct, which I don't recommend doing that. Just hit select remote and then go up to the top here. If you have a Vtx board, that is this. If you have an older KISS V2 board, that's going to be this. So we're going to pick the Vtx. That's what I have on here. If you're looking to purchase a board, I would definitely check out the Vtx just for one reason alone. It accepts VBAT voltage, where the other KISS flight control boards, they only accept 5-volt voltage, which is not that big of a deal with 4-in-1 ESCs nowadays, because a lot of times that will just feed up 5-volt power. But it's kind of nice to have the option to just, wire in VBAT if that's what your desire is. From here, we're going to select our version that we want. So I'm going to go ahead and pick the latest, which is up here on the top. And if you don't have RC46-1 on there, it looks like they're all release candidates. It's one of these, seems like some of these flight firmwares are always in a release candidate mode. They never get to an official release. But I would just pick the latest RC, I guess. Make sure it's 46i or higher. There's a bug fix in here for a D-term, PID loop D-term bug fix that apparently is pretty important. So make sure you get that. If you're seeing this video on your old KISS firmware, there you go. Make sure you get the latest and greatest for this D-term fix. I don't exactly know what it is, but nevertheless, we want to make sure we have that. Going to hit download firmware, and then from this point hit flash, and it should flash it over. It's going to reset everything on your flight control board. So if you already have KISS, obviously you know about how you can save your settings out, which I'll show here in a second, but of course want to make sure you do that first. Once it's done, it will say successful, and then reconnect. Since I already had this firmware version on it and I reflashed the same thing, it looks like it did not reset all the settings, which is unfortunate, and I was kind of looking for it to do that. You can see there's a language selector here because I don't see any button on here to reset everything, which I have this already set up, so I'd like to go through it from defaults, but I don't have a button here to reset it, so I'm going to go ahead and undo all these settings here. It'd be nice to have a just like a reset button to reset all the settings to stock defaults if you get things messed up or just want to see what it is stock again. Okay, I got everything back to the way it was original, so let's go back into the configurator and get it all set up from scratch. So running quickly from the top down, first you have your quad type, so you can see there's just different types of quadcopters here that you can select. Another thing that don't gloss over here is the motor remapping. Honestly, I glossed over this and I rewired all the motors twice because I kind of assumed it was a certain way. I didn't look at the graphic all that closely. Then I noticed I had to do it again. So yeah, I could have just selected this rotor remapping. It was right there to set it to whatever Betaflight uses, which is what I'm used to. The next is selecting your receiver type here. I am using Express LRS, which uses the Crossfire protocol. So you would just select this TBS Crossfire down here at the bottom. Obviously, you have a bunch of different options here. Notice there's a FR Sky S-Bus, inverted, non-inverted. So this is, in Betaflight, there's some CLI values we can change. Here it's just, are you using inverted S-Bus or uninverted? You can select whichever one you want there. Same thing for F port, inverted, uninverted. And so that's nice. TBS Crossfire right there is what I want for this one. This is if the next setting down here is if you want it to go into level mode on a fail-safe and seconds. So I'm going to allow it to how long would it stay in level mode, number of seconds if I have a fail-safe. So in the past in Betaflight, I've set that at 2 to 3 seconds. So that's a controversial thing. Leaving it at 0 will just, as soon as you have a fail-safe, it will automatically disarm the quadcopter. I've used it the other way in Betaflight for years, where it actually just goes into level mode for me, and it's pretty nice. So depending on what your environment, take a look at that, but this would then keep it in level mode for a certain amount of seconds. So with that said, one caveat though, is I know in Betaflight, when I would flip into auto level mode, I would hold it for 3 seconds in auto level mode, but you can also set the percentage of throttle. So I would actually set the percentage of throttle right below where a hover is. So it would go into auto level mode and start to slowly descend. I'm not sure what happens with KISS. I would need to test that, but I don't see a throttle setting here. So I'm cautious that it will go, like if I'm at 100% throttle and it fail-safes, will just stay at 100% throttle in auto level mode and just keep going. Obviously 2 seconds at 100% throttle is gonna feel like an eternity. So yeah, I'm not sure about that. I haven't tested that yet. Maybe somebody that uses KISS can drop a comment down below to clarify that option. Next thing down here is presets. KISS has all kinds of presets. So you have 0 PIDs, which you would not use, defaults, which is what we have here, and you have to actually click the use button. So if you set this to 0 PIDs, for example, then it just zeroes out all the PIDs. Obviously, you cannot use that for a quadcopter. You need a PID controller. And then the other option over here is user. So you can set to user, and then you have all kinds of users here for PIDs. What would be really nice up here at the top is some sort of searching thing like Betaflight 4.3 is going to have, where you could start to type in like Mr. Steel. I mean, come on, who's not going to search for Mr. Steel in those presets? But if you do look down through here, he is there, so you could keep going down. I don't know, you got to find it somewhere in here. Monkey, blah, blah, blah. I don't know, it's in here somewhere. Mr. Steel, MR. There he is, Mr. Steel, and you can see the quadcopter size and then a brief description after it, and there you go. As you look down through these, you'll see that most of them are the 5-inch quadcopter class. There's not really, I didn't really see anything that's larger. It's a little difficult because it's in millimeters. It's 200 to 300 millimeters, like a 250 millimeter quad. There's 100. I saw 100. There's a 110 millimeter quad Falcon 130. So there you go. That's a kind of a smaller preset. So yeah, different presets there. I'm sure mileage will vary. So take these with a grain of salt. It'd be nice if there'd be a little bit more filtering options. Like you could pick the quad class size since they're capturing that as a field, and then I don't know, maybe sort them a little bit by user, things like that. After you pick whichever one you want to use, you go ahead and click use on this side. So you hit use over here, and then it's just going to adjust these PID gains. And I would guess TPA, but I doubt people mess with TPA too much. It's going to adjust these PID gains to use what they're using. On the flip side of it, if you do some custom PIDs there that you have you can go ahead and hit share, and then it will bring up this screen right here where you can put in your name, the quad class. You can see it goes up greater than 500, and then this is kind of the less than sizes you have options for here, and then a description of that, and hit publish. And I would presume as soon as you do that, it would then show up now on this list for user presets right here. It's kind of interesting because one of the reasons I'm doing this testing is because everybody says just KISS on defaults is just amazing. So, but on the flip side, there's a lot of presets there. Then why is there so many custom tunes if the default is so, why would you need to touch it? So I'm sure that we'll need some tuning, but let's see what we see. But it's just one of those things. Again, you have all those options, go through, check them out, and see which one you like the best. The next tab here is your PIND. These are your gains for your PID controller, and then you have your TPA values here as well. So this is the amount of TPA attenuation that you're going to get for your P term, I term, and D term. It's going to follow this rate curve on this side, and you can see these same things. So you get replicated screens, right? So this PIND grid that you see here is the same grid that you're seeing over here. Your rates, your RC rates, see this grid right here? That's the same thing you're going to see right here. You do have down below your level mode PIDs. So these are, again, gains to adjust how strongly it's pushing to level mode. So a higher gain here would be more snappy response back to level. Think of it like a rubber band. The higher those gains are, the faster your quadcopter is going to snap back to auto level or to center. If you have that gain really low, when you move the stick off to the right, the quad's going to slowly move off to the right. If you move that gain really high, that as soon as you move your stick to the right, your quad's going to snap to the right. And then obviously if you move the stick back to the center, the quad's going to snap back to the center. So the value of that gain is almost how elastic your quad is going to follow the sticks based on auto level mode. Keeping in mind that auto level mode is a PID loop all in itself. So with that, you're going to have these gains down here to adjust how elastic it is to that in that PID loop and how elastic it is to following your auto level commands. And again, there you have P, I, and D. Those same fundamentals on PID tuning for this grid up here applies down here. They're both PID loops. One is flying the quadcopter. The other is just controlling how elastic the rates are in sticking to your auto level position or your sticks. And if you want to know more all about PID tuning, I'll drop a link down below. You can check out theuavtech.com/tuning. And I have tons of videos on PID tuning, and that's obviously across the board on tuning KISS, tuning Betaflight, tuning Flight 1, tuning your level modes, tuning the PID loop that also works with GPS modes. So anything that's a PID controller, those fundamentals apply. The final value down here is the max angle. So this will adjust if you're, move your stick to the right, how far is it going to let it go? Is it going to go to 50 degrees? It's going to go 60, 70, obviously 90 would be problematic. So you can adjust that accordingly. Starting from the top over here, you have your min throttle, max throttle, min command, max command, or mid command. So these are going to adjust your stick positions. So if, say, your sticks are off center a little bit, you can adjust this center point right here. So by default, most flight controllers work from a range. It's the old PWM range from 1,000 to 2,000. And you can see in here that's anything different. You have a min and a mid. And based on the min and the mid, it's going to determine the max. So 1,000 to 1,500, that will result in a range from 1,000 to 2,000, with the midpoint being at 1,500. That's how you want to really have it set up. If your radio is not set up that way, you want to get your radio set up that way. There's lots of videos out there on the internet, so we're not going to go into the details on that just yet. Here we have our different protocols. So you can see we have down to PWM, and then it steps kind of up through how things were going. The latest is the FETTech 1-wire. KISS runs at a 1K PID loop, so really you could deal with D-Shot 150 and it would be fine. But I think KISS really beats the drum that sending the motor signal update frequency higher than your PID loop is what they'd like to see. So the default here is D-Shot 600, which is an 8K rate. So we're going to leave that as the default. We're going to get that default experience. The next thing here is your Aux mode. So this is similar to Betaflight for your modes tab. So you don't have the sliders to adjust. So really just have the selecting the Aux mode that you're going to want there. So this would be Aux 1, 2, 3 on your transmitter. So these would be the sticks up top here, right? So I know Aux 1 is going to be what I want for arming. And then you don't have those ranges like you might see in other firmwares where you can set the sliders to different little ranges on this, thing that goes from 1000 to 2000. But here you can kind of pick the low, medium, and high so you can line things up. So high is going to be when the stick is towards you or down in this scenario, and low is going to be when it's up. So I'm going to go ahead and set that to high. It's only a 3-position switch, right? So I'm going to set that to high here. So when this arming switch is all the way towards me, it will arm the quad. Level mode, I'm going to go ahead and set that to 2. I'm going to set that at medium, so when I move that switch into the middle. Buzzer, I'm going to set that to 2 as well, so that's when it's all the way towards me, the buzzer goes off. LED, you have turtle mode, I'm going to set that to aux 3 when that switch is already all the way towards me. You have options here for run cam split, for real pit mode if you're running that, and then also a return to home option, which is really nice that's in there. GPS and assisted return to home now with KISS, so that's in there as well. So you can go ahead and get that all set up. At this point, you have a filter settings here, and this is kind of an all-in-one filter setting. Now keep in mind that high is next to off. So that's the default, so it's having the low pass filters up basically as high as they can be versus just off altogether. If you have a noisy quad, that may be too high. So do keep that in mind. You might, if you want to be more conservative, start at medium or something lower than that. But I'm going to leave it at high and see what I get and go from there. This setting will adjust. You'll see advanced settings here with low, medium, and high. And you can see if I adjust this to medium here, and hit save, then when I go to advanced, these are medium here as well. So this will overwrite. So if you adjust this, it will overwrite whatever you have set here. Here is where you can customize some things, and we'll talk about there in just a second. Off to the advanced tab, this is going to be your configuration orientation of your flight control board. So in here, I do need to do a custom orientation. All the FETTech and KISS flight controllers have an arrow on the top. So if you have that arrow facing towards the front of the quad, you shouldn't need to adjust this. But for me, I have that facing the back just so I can access the USB port on the flight controller. I'm going to need to adjust that to have 180 degrees here because I flipped the board around. And what you can do with that is once you can, check and confirm your orientation, you can actually come over to this graphic under data output and then check your orientation. As you can see, that quad in the model here is facing away from you, right? So as you pick up the nose, you should see it lean back and then to the right and to the left. So if you face the quad on your desk away from you, that's how you can use that to make sure the orientation is correct. I thought it would be really neat here that, in Betaflight, there's like a big arrow on the graphic here. Could really use like a nice arrow to tell, because initially I had to ask somebody about that. I really didn't know which direction. Was the quad facing me or was it facing away from me on this graphic? From here is just a checkbox if you have reverse props or not. If your props are going in the front, then leave this unchecked. If you're having them as in the front, they're rotating away and out, then you would check that. That's reversed. This is launch mode assist. So if you're into racing, KISS does have launch mode where you can tip the quad up and kind of hold it. And then once you initiate throttle, then it will kind of punch forward off of the race gate. Next is deadband. I usually set 3 to 5 on the deadband here. You don't need to do that all the time, but I have Hall effect gimbals and I see some jitter in there. So I usually set this again to 3 to 5 here just to avoid any weirdness. And you can see I had it already set to 5. I forgot to reset that. The next setting right here I would go ahead and check that. This is, they say if, you only go in here if you're really advanced, but it was very confusing to me without this checked because I was like, where is the ports tab? How do I set up what I have going to the different UARTs on my flight controller? So I would check this, hit OK, yes, I know what I'm doing. And this is as simple as, this is where you tell it what things are going to what UARTs on your flight control board. And the reason I wanted to get into this is because I do have a logger set up. So I wanted to set that to logger. I have that going to UART number 3. So if you did not wire it up your receiver to UART number 2. You might need to change things around here a little bit, so on and so forth for the VTX, things like that. I think this is checked and has that warning for, you really need to know what you're doing kind of a thing, just because if you follow exactly to the T how to wire stuff up from Arduino and KISS to the flight controller to this very specific UART, then you wouldn't need to go into here unless you wire a logger, because wasn't even an option. But that's why I think they're saying, hey, it's very, I don't know that it's that risky of a dialogue to go into, so I don't know if it warrants all that warning screen, but nevertheless, if you do, check that on, then you can select what you need here for, OSD, logger, receiver, VTX, telemetry coming back in, run cam, GPS. You can see in here DJI, MSP. That's important nowadays. I would think a lot of people are using DJI. So DJI support is there. You can check that on, and then you can have that available for setting up your DJI OSD overlay stuff. Moving right along, next thing down here is your logger. So we're going to set that to 100% logging rate. And I am using on this a open lagger, which does work fine at 100% that I've seen so far. I'm going to head ahead and select the debug mode. So I'm going, you know me, gyro scaled for my debug mode. So this is an external logger that I'm wiring up to UART3. Not that it's full of bugs, but at least I'll get some sort of log. So that's one thing with KISS. Don't expect, KISS has logging, but it's buggy. It's semi-useless. You will see there's going to be more content on that, but like the rates aren't scaled right. The debug mode for raw gyro noise is not recording correctly. So it's just, I don't know. It's there, but I don't really count on it. The next thing down here is Vtx configuration. So you have just a dummy VTX. I don't have smart audio connected, but you can see your different protocols here that you can select. And then from there, you can select what band and channel you want it to be on. And then your min to max power. I guess this is low power, and then high power. This is if you're using with your pit mode and turning power on to lower or high. It's kind of interesting in here because I know how smart audio works. So there's multiple smart audio versions, and the power inputs to them are different. I wonder if they're coding that in the background or this just doesn't work right. So I would confirm this is working correctly because, again, when you select smart audio, there's multiple protocols. There's smart audio 1.0, 2.0, 2.1. So which one does it know how to use since you're not telling it here? And then, so maybe detecting that in the background, but then also it would need to translate these because in Smart Audio 2.1, this turns into a DBI thing. Don't worry about the details of it, but it's not so simple as just inputting these power levels. So I'm a little cautious that that's going to work correctly. So I would definitely test it out and make sure that that's going to work right. But the intent here is that you'd select the protocol you're communicating with your VTX, select the band and channel you want to be on, and then put it on to the low setting for when you're in pit mode, and then the high setting for when you're ready to fly. Next down here is buzzer emulation with the motor, so I'm going to check that on me personally because I don't have a buzzer wired up, so I'm going to use the motors as the buzzer. So never fly without a buzzer for sure. Down here we have LED selection, so you can pick different LED colors and set the amount of brightness, and that would work obviously with the aux switch that we had set for LED, so you can check that out. D-term set point weight is really the stick feel. This is kind of like a feed forward. It's the old D-term kick. So if you want a stock PID controller with no advanced like feed forward / D-term kick kind of a thing to get the quad, following the sticks really close, you would set this to 0. And then it's just a PID, and that's it. If you set this to 100, you're going to get a D-term kick. But if you have a lot of D-term noise, that kick is going to feel a little erratic. Actually, you're going to feel a little erratic either way with a lot of D-term noise, but it'll feel twice as much erratic with having a higher set point weight. So at the end of the day, if you like high amounts of stick responsiveness, so like kind of a racer, you would want to set this to 100. If more freestyle, mushy, and don't care about latency or lag and that it's not really following the sticks, there's kind of a delay between when you're moving the sticks and when the quad's actually moving, then you would probably want to set this down to 0. Adaptive filter, from what I understand, is a pretty important filter. Some speculate it's kind of like a dynamic notch. So, I would check that on. I think everybody runs with the adaptive filter on. I'm going to do some testing with that on or off and see what the differences are. These are the standard notch, static notch filters. So again, here, if you have a specific issue, you could use these to target it. But again, the logging, you'd need to know what the center frequencies are of this like peak noise that you need to deal with. You would need logging to do that, and the logging is kind of a little off. So I can't imagine anybody's checking these on or using these just because you'd have to have a logger. First of all, you'd have to get hooked up, and then the logging's buggy, and you can't really tell what's what. Here down the drop down, so you can kind of customize your roll pitch, low pass filter, yaw, and determ. Again, this will, if I set these now here, so say I set these back to high, and just leave that as medium. And then I go back to here, you can see this says advanced settings now. So if I would adjust this then back, it will overwrite these back to whatever this setting was here. Now this setting, the yaw filter strength has to deal with the amount of notch filter strength that is applied to the yaw axis. There's not a ton of information out there on exactly what this does. So I'll drop a link down below on a resource you can go read on that a little bit more, but it seems like it has to deal with maybe these notch filters up here or the adaptive filter, which is presumed to be some sort of dynamic notch. For the next thing down here, we want to look at battery voltage. So this would be your minimum cell voltage that you want to see on an alarm, and then times whatever your cell voltage is. So this is going to be a 4S quad, so it's 3.5 times 4, so 14 volts is what I'm throwing into there. Obviously, if you have a 6S quad, that would be 3.5 typically times 6, and that would be 21 that you'd want to put in here. This is the amount of milliamp hours drawn. You can see the DJI OSD. This is your layouts, your units, crosshairs, GPS. So you have some different options here you can turn on, and then it will, display a certain pre-configured OSD. So you're not going to be exactly choosing where to put the stuff. You can just have these presets. I would guess they would be best terminology for them. And then what units, and then whether if you want to have crosshairs or GPS on or not. The best way to get that set up, I would assume, is get everything connected, plug in, make sure it stays cool enough, but then obviously just see what it's going to use in the OSD as you're configuring stuff up. Of course, you're probably going to have it plugged in, so make sure your props are off, things like that. Finally, down here under the KISS return to home, if you have a GPS module set up, we would have set up over here, just like we did for the MSP, you can set up different things for your max altitude. You can see as 0, everything's on auto, and you can see your max height, your distance radius, and it does have a return to home on failsafe option here, so you could check that if you want it to automatically return to home, which obviously would make some sense. And your home action, which would be loiter until the LiPo alarm. See, they have some nice options here. So in this, I don't know if it just loiter, obviously if it just loiter around, it's whenever the battery dies, it will just slowly come down because the battery doesn't just shut off. It's gonna start to slowly come down. So you'll get a soft landing that way. In this regard to until the low alarm, I don't know if when it hits the low alarm, does it start to reduce throttle using the GPS altitude to kind of bring it down, or is it just disarm? Again, if somebody down in the comments knows which behavior you get there. And then this final action here, of course, is that when it gets near the home position, it will just go ahead and disarm. Moving on to the motors tab, you have some different options here. You can see this is where you're going to check your output of your different channels.
Welcome to OpenTX.
So one thing with KISS that's kind of irks me a little bit is they do not have channel mapping. So the only way to remap your channels is in the transmitter themselves. You have to have it set that channel 1 is throttle, 2 is roll, 3 is pitch, 4 is yaw, and then aux 1, 2, 3, 4 all the way up to 7 for your different channels. So this would actually be channel 5 would need to be aux 1, right? Channel 6 is aux 2, 7, 3, so on and so forth. So you have to have that set up in OpenTX in your radio. I'll look for a video on that and drop a link down in below. But then obviously you can see here, once you have that set up, you can confirm your channels are moving correctly based on the stick inputs there. Also in this tab, you can go up to hit motor test, and here again, you're going to get a warning making sure you know what you're doing. Props are off. And then in here, you can go ahead and select that one, hit that icon. And then at that point, you can check this box again, and then you can pick which motor you want. And then with the LiPo plugged in, power up each one. What is a little different about this is you have to have your transmitter plugged in. You have to use your transmitter to do this. So you'd have this plugged in, props off, make sure props are off. But I mentioned props need to be off specifically for KISS. Even with Betaflight, you don't have the props off. I would make sure you do it for here because you're using your transmitter and all kinds of stuff. And it's just make sure your props are off. Enable the motor check. Check which motor you want to power up. So if you want to check the, that everything's wired correctly, then you check on this. It would power up motor PWM2, which would be this one. And obviously you want to make sure that the right front motor, when you go to raise throttle, starts to spin up. And then if it doesn't, if some other motor is spinning up, well, then you have it wired wrong. You have to either check a different thing in the motor mapping or just rewire the motors manually. So that's how you do that. And then you have to drop throttle down to 0 to uncheck and then check a different one. And of course you can check all of them all at the same time if you want and power them all up all at the same time, whichever you want to do there. As always, before going out and flying, you want to have your quad flat on the desk, come into Calibrate Accelerometer, especially if you're using any kind of level mode, and make sure that it's facing forward and level. Check your orientation like we talked about earlier, and you should be good to go there. Finally, you have your rates tab here. You can adjust your rates. You can't pick a max rate here, so you kind of got to look down. You can see here, this is a really high rate here. So I'm going to bring this down to, this rate indicator right here. It'd be nice if you could just type in like, I want 1,000 degrees per second, kind of like you can now in other firmware. But you can use this to just take a look here and set whatever you're looking for your rates there. Obviously, as you adjust, it doesn't seem like this one adjusts really much of anything, at least on the rate curve, because if I set that to 0.1 or to 1, it doesn't really seem to do much, at least in the rate curve. So I don't know if that's a bug or it just really doesn't do much. The RC curve, though, however, does. So if I set this to 0.8, you can see it curves out, and you can get, I wonder if you can set that to, yeah, whew, that would be a good time. So yeah, I guess don't set this above 1, or it's gonna be strange for you. That would be kind of weird. So as you go right, the quad will go left, and then it will start to go back right again. So just get a buddy that uses KISS, go in his configurator and set that to like 5, and that'd be a little practical joke for him. Don't set that above 1. I'm surprised that it lets you do that. So just be careful with that. 1 is going to give you a really flat and docile right at the center. So that's maybe a little too extreme, but if you're doing freestyle, this is kind of similar to center stick sensitivity in Betaflight for the actual rates. So, maybe a higher value if you want it really nice and mushy at the center, and then maybe a little bit more. I'm still getting my max rate at 1,000 degrees per second out here. And finally here, we're on TPA. So on TPA, the simplest thing to do is turn your radio back on, and you can see what will occur here. So how this works is, this is your percent of reduction of the PID. So you can see here, as I move this down to 0%, I get full PID gains, right? And then if I move this up, I get, you can only go up to 0.9 is the most amount. So you can only reduce your PIDs down by 90%. So that is the default, I guess, TPA action. However, there's an influencing factor, that's this rate curve. So this is TPA influence. So when you look at this, this is 30%. So I think the easiest way to comprehend this, I guess, is let's set this to 0.5, right? So we'll set that to 0.5. So that's a 50% reduction in the PIDs. However, right now we're at, a 0% influence, right? If I move this down to 0%. So you have a 0.5% reduction on PIDs in the TPA, but if you're applying 0% of that, then it's none. You can see there's 3.0 here. So if I want a half reduction of the PID, I can set my influence here. So if I get a 100% influence at 0, because I'm at 0% throttle right now, you can kind of use this indicator stick, right? If I'm at 0% throttle and I want 100% of my TPA influence here, or my TPA, which is half of the P gains, I'm just dealing with my P gains right now, then you can see 100% of that, 100% of 50% is half of the 3. So you have 3 times 0.5 is 1.5. So you can kind of see how the TPA and percent influence are two different things. It's a little different, a little confusing if you're not used to it. Now I gotta be honest, I'm a little confused on the influence curve. I don't see why you'd have lower PID gains at 0% throttle. You'd have full PID gains at mid throttle and then have low PID gains. That part makes sense, the lower PID gains at 100% throttle. I think that's better for prop wash performance. I guess that would be the thing. If you have lower gains at low end and high end, that means that your PIDs can, as you're tuning it out, will be generally higher. And then once in mid throttle, those PIDs are going to be even higher, because if you're setting your PIDs kind of on these low ends, because like when you're doing flips and rolls, think about it, you're at 0% throttle, right? And that's when we're checking out our PD balance. The only difference is in my tuning practices, you're doing two different things, right? You're doing full flips and rolls, which when you're doing that, obviously you're at 0% throttle, right? Because you punch up, drop throttle, and hit a roll right, and then you'll see if you get bounce back, right? So you're tuning your PIDs based on that to some extent. But I also have it that, if you're at mid throttle cruising forward and you're doing the twitch moves back and forth, right? So in that, we're catching that mid throttle tuning or PID gains if you're going into the level of tuning detail. With KISS, if you're not doing those middle twitch moves, what will happen is when you're actually in mid throttle position, which is where prop wash, you're usually at from like 40 to 60% throttles where you're going to get prop wash. Your PIDs are going to be boosted even higher, so it might be a good approach for prop wash. Again, that's their default. That's how the TPA curve stuff and influence curve stuff works. If you would then want to adjust this influence curve, you can again see this indicator here with your throttle percent, and then you can come into here and adjust. So if I wanted this to be 50% throttle, or say 30 is good there, I think this really could be 60. And then obviously if you wanted to adjust this down to say 80% influence, but again, it's like a double influence thing, because it's 80% of 40% is how much the D gains in this example are brought down there at when you're at full throttle on this side. So yeah, unless you want to really customize that, you might just want to leave all that alone, but that's how it works. So that is it for the KISS GUI configurator. I think there's a bunch of stuff in there that, hopefully I covered that I don't think is out there in other content. With the, it being simple, I think it's fairly straightforward. I don't know if it's all that simple. I think Falco X is probably the simplest nowadays with its wizard setups. But you can see in there, apart from the TPA thing, which is kind of confusing, maybe just because it's new to me, everything else is, fairly straightforward. One thing that we do have to keep in mind is some of the things you would leave behind. And I think people don't cover this enough with KISS. The reason I bring this up is there's typically a sentiment with KISS that, hey, we're keeping it simple. We don't need this other stuff. And that may be the case if you don't need other options. But here's some of the things that KISS doesn't have that open source firmwares like Betaflight, iNav, EmuFlight, CleanFlight do have that you may or may not need depending on your quad class. So anyways, that is it. Hopefully that gives you a good run through on exactly how everything works in KISS and the configurator, and kind of a snapshot between the two, compare and contrast. Finally, the determination on whether you need those options or not is ultimately up to you. It's your quad and your craft. So there it is for you. If you have any questions, leave them down below. If anybody knows some of the things I was a little fuzzy on, I'd enjoy those comments down below. I can pin what I can only pin one comment, but pin the best one that's most relevant to something I was a little fuzzy on. I think there was like 2 things there to help clarify those. And again, any questions down below. Appreciate your time. Thanks everybody, and I hope this helps.